Hello everyone. In this video, we are diving deep into the exciting world of object detection, the tech that powers everything from self-driving cars to smart security systems. We will be building our own project using the latest and greatest YOLO V8 and ResNet 50. I'll walk you through how this powerful real-time detection model works and why it is a game changer, and how you can use it to detect objects in the real world. So if you're ready to turn your camera into smart, real-time vision system, let's stick around. Let's get started.
Imagine a system that looks at traffic footage and instantly tells you not just what kind of vehicle it is, but also its color. That's exactly what we have built. Our solution works on both image and video, and it is designed to stay accurate even in busy traffic or poor lighting. This kind of smart detection can make traffic monitoring faster, smarter, and more reliable for real-world use.
The main aim behind developing this project was to build a real-time object detection system using YOLO V8 and color detection using ResNet 50, capable of accurately identifying colors and types of the vehicles in live video streams and images, making it suitable for applications like surveillance, smart security systems, autonomous driving, and much more. For this project, we've made use of technologies like ReactJS to develop the front end, which was built with White and TypeScript. ReactJS is fast, interactive, and user-friendly. Programming language we have used in this project is Python for machine learning, API integration, and for backend development.
Deep learning models used in this project are YOLO V8 and ResNet 50, whereas for backend development, FastAPI and Node.js is used.
Now rises the question, why use YOLO V8? YOLO V8, that is, You Only Look Once version 8, is a state-of-art deep learning model designed for real-time object detection, segmentation, and classification. YOLO V8 is widely known for its speed, accuracy, and efficiency. It was built on the strengths of its predecessors while incorporating cutting-edge technologies for even better performance. YOLO V8 is light, easy to deploy, and highly flexible, making it a go-to choice for applications ranging from autonomous vehicles to security systems and much more.
Why ResNet 50? First of all, it is very good at understanding pictures, so it can easily figure out color of vehicles. The best part is we don't need thousands of images to train ResNet 55. Even with a small dataset, it works well. It is not too large or too heavy, so it works faster. It is also very easy to use in our code because it is available in tools like TensorFlow, Keras, and PyTorch. So we didn't have to build a new model from scratch. Another big advantage is that ResNet 50 can handle many images together.
The dataset used for training purpose of YOLO V8 and ResNet 50 was Top View Vehicle Detection Image Dataset from Kaggle website. This dataset consists a total of 536 training images and 90 validation images. This dataset consists of variety of types of vehicles like car, bus, truck, and motorcycle, and a wide range of colors from which we have extracted only 6 color classes.
Approach. We start by preparing the data through a careful annotation process. We used Label Studio, which helps to easily mark and categorize vehicle in the image. Goal here is to prepare structured data, which is essential for building accurate model.
Let's have a deeper look at the script that we have used for labeling our vehicles. As you can see, in the view tag, we have specified rectangle labels tag. We all know that we want to draw a bounding box around our object, that is vehicle in this case. Let's move to the next slide and understand what this rectangular label stands for. Suppose you have a car and you want to draw a bounding box around it. You select the particular type of the vehicle and the color and draw a box around it. As the box is rectangular in shape, that's why we make use of rectangular tags. Let's go back and understand the labels. So for labels, we have made use of 4 types of labels for type detection. That is car, truck, bus and two-wheeler. The order of labeling the vehicles does not matter here. You can choose any order of your choice. We have made use of labels that is 0 car, 3 truck, 2 bus, 1 wheeler for ease of understanding. Now let's understand why we have made use of background. The background specifies nothing but the color of the box. Let's consider, for example, the first tag, that is label value 0 car background given a hexadecimal value, that is orange red. Orange red. Let's move to the next slide. Here we can see that 0 car is given the color orange red. So similarly, to differentiate easily between the type as well as color of the vehicles, we have given each of the labels different colors. Similar script is repeated for color of the vehicles, that is we have taken 6 color classes: red, blue, black, white, yellow and grey. Let's move to the next slide and understand how we will be able to annotate a particular image. Suppose you want to annotate a white car. Let's say in the first image you want to annotate a white car. You choose car label and below that you choose white label and you draw a bounding box around that particular car. In this way, a label will appear for that car as white car. Similarly, you will go on repeating this process for each car in a particular image and for entire training dataset as well as validation dataset. In this way, you will get a labeled dataset as output.
I would also like to add a note to this. You will wonder why this bounding box is of blue color when the color of bounding box for car is orange. Reason is we are overlapping vehicle type label with its respective color label. So there is orange bounding box representing car beneath blue colored bounding box. Label preparation. So for labeling, we used YOLO V8 format to label each vehicle. We gave each vehicle 2 labels. So for each vehicle there will be 2 entries in label.txt. One for its type and another for its color. But they will be sharing same bounding box, hence same bounding coordinates also.
Now let's understand this in greater depth. You can see in the following image a classes.txt file. This classes.txt file consists of all the labels that we have chosen for our model, that is type of vehicle as well as color of the vehicle in sequential order. Now, whenever you finish annotating all the images in your training as well as validation dataset, you export it in YOLO V8 format. After exporting it, you get a folder which consists of labels. These labels are in txt format. Now you open any of the label for a particular image. You'll get the following figures as output. Now, let's try to understand these figures. In the label.txt file, for a particular image, we have gotten 5 columns. The last 4 columns stands for the bounding box of that particular vehicle in a particular image. For each image, a different label.txt according to that image will be generated. So this file that is displayed on the screen is for a single image only. In this image, there are multiple vehicles and their bounding box coordinates are represented. Let's understand the first column, that is the type as well as the color of the vehicle. Consider the first line. In the first line, you can see 7, which stands for color red. And the next 4 columns are the bounding box coordinates of that vehicle. Now, as you can see, the first coordinate starts with 0.79. We'll try to locate similar coordinates in the file below to check the type of the vehicle. As we can see, as we move below, indicated by the arrow, we can see that 0.79 has 0 as its first column, which indicates the car. That is 0.79 is the bounding box coordinate of a car which is red in color. Similarly, for each vehicle, its type as well as color label is generated.
As I mentioned earlier, we are using YOLO V8 format for labeling. But for ResNet training, we need actual files which contains images of each color, that is black, blue, gray, red, and etc. So we used a script to solve the problem of mismatched input format, which I will explain further.
Now let's understand the training process of YOLO V8 model. Through labeling Studio interface, we have got an output in YOLO V8 format. This output will be fed to YOLO V8 model for training process. For this, you need to install all the necessary libraries, and you can perform the training process on Jupyter Notebook as well as Colab. You can train the model according to your training dataset size and use early stopping to avoid underfitting or overfitting. Through our training process, we have achieved an accuracy of 76.22%, precision of 75.74%, recall of 76.22%, F1 score of 75.36. You can further fine-tune the model for better results.
Training ResNet 50 for color detection. As I mentioned earlier, there is a problem of mismatched input format between YOLO V8 and ResNet 50. So we wrote a script for solving the problem of this mismatched input format. The script reads bounding box coordinates from color label to crop out each vehicle from image. Cropped vehicle images are then sorted into folders based on their color. Let's take an example. 4 is class ID for black color. So image cropped will be stored in black colors folder. Result will be multiple folders named by color. These folders will be automatically generated by script using labels which we have provided to it. So this script will accept two inputs. First will be image and another will be label for the same image. According to the label, it will store cropped images of vehicles from image to organized folders. Hence, all vehicles will be organized in folders according to their colors. ResNet 50 model will then get trained on these images. For training, you can use Jupyter Notebook or Google Colab. You have to import all the necessary libraries to perform all the tasks.
Now let's develop the front end for our application. The need for developing the front end was to provide a good user experience. Now, we all know that it is a tedious task uploading each image using a script every time and getting the output. So, we tried to develop a front end for this application using ReactJS. As you can see, in the front end, we have displayed an option for the user to choose a file. A pop-up will be displayed wherein the user will select a sample image as input and that image will be uploaded. The result will be annotated image. If you want to choose another file, you select upload another file option. This is a simple yet intuitive front end developed for the ease of access and ease of use for the users. We have also provided dark mode feature as an extra additional feature to make this website more interesting. This is the folder structure in which we have created components like card.tsx, navbar.tsx and sidebar.tsx. Sidebar for developing a collapsible sidebar for our front end. Navbar stands for the navigation bar and card.tsx which holds the main function of uploading an image and getting the processed image as output.
Backend testing. We have used FastAPI for serving machine learning models. And here we are using Swagger for testing our backend APIs because it is efficient and developer friendly. Swagger provides an interactive interface to test, view and document API endpoints directly from browser. It saves time by auto-generating documentation and allows real-time testing without needing external tools like Postman. Plus, it supports standardized API design and client SDK generation, making integration smoother. In short, Swagger makes API testing faster and more organized. Now, let's see a demonstration of FastAPI. Here, we'll choose an image from our desktop Then we'll upload it and execute it. So we are getting 200 as response, which says that our backend is running correctly. And here is what our expected outcome.
So here is a final output, that is front-end and back-end integration. Herein we choose a sample image as input and get the annotated image as output. We can also choose multiple files to test our website. So here we take another image as input, and as you can see, we get correct and accurate output. We have also added dark mode functionality and a collapsible sidebar. It is a simple yet intuitive application.
And that's it for today's video. If you found our project interesting, make sure to check out GitHub link in description box below. And please don't forget to like, share and subscribe. Thank you.